Hello everybody. Here at Hydroflow USA, we are often asked how hard water can be made in order to conduct lab experiments to verify the performance of our unique technology. The equipment we will be using during this lab demonstration is compound microscope with eyepiece camera, two 3000 milliliter beakers, two 500 milliliter beakers, pipette, magnetic stir plate, CO2 inflator with tubing extension, two number 4 coffee filters, one inside of the other, a TDS meter, one bottle of calcium carbonate, also known as CaCO3, testing strips. To make your hard water, you will need the following ingredients: 2,000 milliliters of distilled water that's around 5 degrees Celsius, which is 40 degrees Fahrenheit, 6 grams of calcium hydroxide, 3 grams of magnesium sulfate, 3 grams of calcium chloride, and 1 CO2 cartridge. The list of ingredients and equipment can be found in the video's description. As you can see, distilled water has virtually no TDS, or total dissolved solids, in it. That's about to change. Use a magnetic stir plate to mix the solution until all the ingredients have dissolved. 6 grams of calcium hydroxide, 3 grams of magnesium sulfate, 3 grams of calcium chloride. After a few minutes, turn off the stir plate and pour the cloudy mixture through the doubled-up coffee filters to remove the undissolved minerals. Since one coffee filter filters down to approximately 20 microns, the solution should be noticeably clearer. As you can see, the solution's hardness went up from 2 to 3,540 ppm. We will now pour the solution into two 500 milliliter beakers. Using a calcium carbonate test strip, we can verify the solution's hardness as CaCO3. In this case, the calcium carbonate hardness is 425 ppm or higher. It's the highest level on the test strip. This concludes the explanation on how hard water is made. Now for some bonus content. We simply need to introduce carbon dioxide, also known as CO2. In this case, we're using a CO2 inflator we purchased on Amazon. The water becomes cloudy as the calcium precipitates out of solution as CaCO3 and causes the TDS, which means total dissolved solids, to become TSS, which means total suspended solids, also known as hard scale. We will now perform the same CO2 introduction on the second beaker that has had an energized Hydroflow device around it for roughly 30 seconds. Please note the CO2 inflator can be a little finicky and may cause some of the solution to splash. In the future, we plan to post another video which demonstrates Hydroflow's ability to reduce hard-scale accumulation from a boiler's heating element. Now that we have a cloudy solution, we know the water is full of calcium carbonate crystals. Let's examine them under a microscope to determine if there's a difference between the two beakers. The CaCO3 crystals on the left are smaller and more jagged, while the crystals on the right are larger and smooth. Thank you for watching this video. We hope you enjoyed it. Remember to like, subscribe, share, and ring that bell.